These ML concepts confuse even experienced data scientists. How do we split the data into a training set and a test set for model deployment? Answer: we typically set aside 70% of the total data as the training set, which is used to train the model, and the remaining 30% as the test set, which is used to test the accuracy of the model. This allows us to evaluate the model's performance on unseen data and make adjustments as needed. The test set is not used during the training process, ensuring that the model is not overfitting to the training data. This approach helps to ensure that the model generalizes well to new, unseen data. How do you handle missing or corrupted data in a dataset, and what are some useful methods and pandas to do so? Answer: to handle missing or corrupted data in a dataset, you can either drop the rows or columns with missing data or replace them entirely with some other value. In pandas, two useful methods are null and dropna, which help find the columns/rows with missing data and drop them. Another method is fillna, which replaces the wrong values with a placeholder value. These methods can be used to clean and prepare the dataset for analysis. How do you choose a classifier based on the size of the training set? Answer: when the training set is small, it's better to use a model with the right bias and low variance, as they are less likely to overfit. On the other hand, when the training set is large, models with low bias and high variance tend to perform better, as they can handle complex relationships. For example, naive Bayes works well with large training sets, while other models may be more suitable for smaller sets. By considering the size of the training set, you can choose the right classifier for your specific problem. What is a confusion matrix and how is it used in machine learning algorithms? Answer: a confusion matrix, also known as an error matrix, is a table used to measure the performance of a machine learning algorithm. It is commonly used in supervised learning to compare the actual values with the predicted values. The matrix has two parameters, actual and predicted, with identical sets of features in both dimensions. The matrix helps to calculate the accuracy of the model by comparing the values across the diagonal. A high value across the diagonal indicates a more accurate model. The accuracy is calculated by dividing the sum of the values across the diagonal by the total observations in a test dataset. A confusion matrix is a valuable tool in machine learning to evaluate the performance of an algorithm and identify areas for improvement. What are false positives and false negatives, and why are they important in classification systems? Answer: false positives are cases where a system incorrectly predicts a positive outcome when the actual outcome is negative. For example, if a medical test predicts that a patient has a disease when they actually don't, it's a false positive. On the other hand, false negatives are cases where a system incorrectly predicts a negative outcome when the actual outcome is positive. For instance, if a medical test fails to detect a disease in a patient who actually has it, it's a false negative. These errors are significant because they can have serious consequences. False positives can lead to unnecessary treatments, procedures, or even surgeries, while false negatives can result in delayed or misdiagnosis, which can worsen the condition or even be life-threatening. In any classification system, it's crucial to minimize false positives and false negatives to ensure accurate predictions and reliable decision-making. What are the three main stages involved in building a machine learning model? Answer: the three stages of building a machine learning model are model building, model testing, and applying the model. In a model building stage, you choose a suitable algorithm for the model and train it according to the requirement. In the model testing stage, you check the accuracy of the model through the test data. Finally, in the applying the model stage, you make the required changes after testing and use the final model for real-time projects. It's essential to regularly check and update the model to ensure it remains accurate and effective. What is deep learning? Answer: deep learning is a subset of machine learning that uses artificial neural networks to think and learn like humans. It involves systems with multiple layers of neural networks, which automatically determine which features to use and which not to use, unlike traditional machine learning where feature engineering is done manually. This allows deep learning models to learn and improve on their own, mimicking human-like intelligence. What are the main differences between machine learning and deep learning, and how do they approach problem solving? Answer: machine learning enables machines to make decisions on their own based on past data, requiring only a small amount of data for training. It works well on low-end systems and doesn't need large machines. However, most features need to be identified in advance and manually coded, and the problem is divided into two parts, solved individually and then combined. On the other hand, deep learning uses artificial neural networks to enable machines to make decisions with the help of large amounts of training data. It requires high-end machines with a lot of computing power, as the machine learns features from the data it is provided. Deep learning solves the problem in an end-to-end manner, without the need for manual feature identification or division into smaller parts. In summary, machine learning is more general and can be applied to a wide range of problems, while deep learning is a specialized form of machine learning that excels in tasks that require complex pattern recognition, such as image and speech recognition. What are some common applications of supervised machine learning in modern businesses? Answer: supervised machine learning has several applications in modern businesses, including email spam detection, healthcare diagnosis, sentiment analysis, and fraud detection. In email spam detection, a model is trained using historical data of emails categorized as spam or not spam. This labeled information is fed as input to the model, enabling it to accurately identify and filter out spam emails. In healthcare diagnosis, a model is trained using images of diseases, allowing it to detect if a person is suffering from a particular disease or not. Sentiment analysis involves using algorithms to determine whether documents are positive, neutral, or negative in sentiment. Finally, supervised machine learning can be used for fraud detection by identifying suspicious patterns and detecting instances of possible fraud. These applications demonstrate the potential of supervised machine learning to improve business operations and decision-making. Question: what are the applications of supervised machine learning in modern businesses? What is semi-supervised machine learning? Answer: semi-supervised machine learning is a type of machine learning where the training data contains a small amount of labeled data and a large amount of unlabeled data. This approach combines the benefits of supervised learning, where the model is trained on labeled data, and unsupervised learning, where the model is trained on unlabeled data. By using both labeled and unlabeled data, semi-supervised machine learning can improve the accuracy and efficiency of the model, especially when labeled data is scarce or expensive to obtain. What are the two main unsupervised machine learning techniques? Answer: the two main unsupervised machine learning techniques are clustering and association. Clustering involves dividing data into subsets or clusters, where each cluster contains similar data. Association, on the other hand, identifies patterns of associations between different variables or items, allowing for predictions and suggestions, such as recommending products based on a customer's purchase history. What is the main difference between supervised and unsupervised machine learning? Answer: the main difference between supervised and unsupervised machine learning is the type of data used to train a model. Supervised learning uses labeled data, where the correct output is already known, to make predictions on new, unseen data. On the other hand, unsupervised learning uses unlabeled data and allows the algorithm to discover patterns and relationships without any guidance. This means that supervised learning is used for tasks such as image classification, where the correct label is known, while unsupervised learning is used for tasks such as clustering, where the algorithm must identify groups or patterns in the data. What is the difference between inductive machine learning and deductive machine learning in the context of machine learning? Answer: inductive machine learning involves observing instances and drawing conclusions based on defined principles, whereas deductive machine learning involves concluding experiences. In other words, inductive machine learning starts with specific instances and generalizes to a broader concept, whereas deductive machine learning starts with a general concept and draws specific instances. For example, inductive machine learning would involve training a model on a data set of images and then using that model to make predictions on new, unseen images, whereas deductive machine learning would involve using a general rule to draw specific conclusions about a particular situation. What are the main differences between K-means and KNN algorithms, and how do their approaches to clustering and classification differ? Answer: K-means is an unsupervised clustering algorithm that groups similar data points into clusters based on their features. It is an iterative process that aims to minimize the distance between data points within a cluster and maximize the distance between clusters. On the other hand, KNN is a supervised classification algorithm that classifies new, unseen data points based on the majority vote of their K-nearest neighbors. The main difference between the two is that K-means is used for clustering and KNN is used for classification. Additionally, K-means is an unsupervised algorithm, whereas KNN is supervised. This means that K-means does not require labeled data, whereas KNN requires labeled data to train the model. In summary, K-means is used for clustering and KNN is used for classification, and they differ in their approaches to data analysis. What is the reason behind the naive Bayes classifier being called naive? Answer: the naive Bayes classifier is called naive because it makes assumptions that may or may not be correct. Specifically, it assumes that the presence of one feature of a class is not related to the presence of any other feature, even the class variable. This means that the algorithm considers each feature independently without taking into account any potential relationships between them. This simplifying assumption allows the algorithm to make predictions quickly and efficiently, but it may not always produce the most accurate results. How can a system use reinforcement learning to play a game of chess? Answer: in reinforcement learning, a system, called an agent, learns to play a game of chess by making moves, receiving feedback, and adjusting its actions based on rewards and penalties. The agent starts by making a random move, and then receives a reward or penalty for the outcome of that move. The reward or penalty is used to update the agent's internal model of the game, allowing it to learn which moves are likely to lead to a win. Over time, the agent becomes better at making moves that lead to a win, and worse at making moves that lead to a loss. This process of trial and error allows the agent to learn how to play chess without being explicitly programmed with rules and strategies. The system can play a game of chess using reinforcement learning by defining the game environment, specifying the actions the agent can take, and setting the rewards and penalties for each outcome. The agent then learns to play the game by interacting with the environment and receiving feedback in the form of rewards and penalties. As the agent learns, it becomes better at making moves that lead to a win, and worse at making moves that lead to a loss. This process of trial and error allows the agent to learn how to play chess without being explicitly programmed with rules and strategies. How do you decide which machine learning algorithm to use for a classification problem? Answer: to choose the right algorithm for a classification problem, you can follow some guidelines. If accuracy is a major concern, try out different algorithms and test them using cross-validation. If the training data set is small, use models that are less likely to overfit, such as those with high bias and low variance. On the other hand, if the training data set is large, use models that can learn complex patterns, such as those with high variance and little bias. By considering these factors, you can increase the chances of selecting the best algorithm for your classification problem. How does Amazon use purchase data to recommend other products to customers? Answer: Amazon uses purchase data to recommend other products to customers by storing the data of each purchase made by a user and then using an association algorithm to identify patterns in the data. This algorithm can identify which products are often bought together, which products are similar, and which products are likely to be of interest to a customer based on their previous purchases. This information is then used to suggest other products to the customer, increasing the chances of them making another purchase. The algorithm is constantly updated and refined to ensure that the recommendations are accurate and relevant to the customer's interests. When should you use classification over regression in a machine learning problem? Answer: you should use classification over regression when your target variable is categorical, meaning it can only take on specific discrete values, such as yes/no, male/female, or breed of animal. This is in contrast to regression, which is used when the target variable is continuous, meaning it can take on any value within a range, such as sales, score, or rainfall. Examples of classification problems include predicting yes or no, estimating gender, breed of an animal, or type of color, while examples of regression problems include estimating sales and price of a product, predicting the score of a team, or predicting the amount of rainfall. How do you design an email spam filter, and what are the key steps involved in the process? Answer: to design an email spam filter, you start by feeding it with thousands of emails that are already labeled as either spam or not spam. Then, a supervised machine learning algorithm is used to determine which type of emails are being marked as spam based on specific words or phrases such as lottery, free offer, no money, and full refund. Next, when an email is about to be delivered to your inbox, the spam filter uses statistical analysis and algorithms like decision trees and SVM to determine how likely the email is to be spam. If the likelihood is high, the email is labeled as spam and doesn't reach your inbox. Finally, you test all the models and use the one with the highest accuracy to filter out spam emails. This process ensures that your email spam filter is effective in blocking unwanted emails. What is a random forest? Answer: a random forest is a type of supervised machine learning algorithm used for classification problems. It works by creating multiple decision trees during the training phase. Each decision tree is built using a random subset of the training data. The random forest algorithm then chooses the decision that is most popular among the decision trees as the final decision, which helps to reduce overfitting and improve the accuracy of the model. This approach allows the algorithm to capture complex relationships between the input features and the output variable, making it a powerful tool for classification tasks. When given a data set, how do you decide which machine learning algorithm to use, considering factors such as data size, type, and problem type? Answer: to decide which machine learning algorithm to use, you need to consider several factors. First, think about the size and type of your data. Is it continuous or categorical? Do you have a lot of data or a small amount? This will help you choose an algorithm that's suitable for your data. Next, consider the type of problem you're trying to solve. Is it a classification, association, clustering, or regression problem? This will help you choose an algorithm that's designed for that specific problem type. Finally, think about any predefined variables or goals you have. Are there any specific variables you want to predict or classify? Do you have a specific goal in mind? By considering these factors, you can narrow down your options and choose the best algorithm for your dataset. For example, if you have a large amount of continuous data and you're trying to predict a continuous output, you might choose a regression algorithm. If you have a small amount of categorical data and you're trying to classify it, you might choose a classification algorithm. By considering these factors, you can make an informed decision about which algorithm to use. What are bias and variance in a machine learning model, and how do they affect the performance of the model? Answer: in a machine learning model, bias and variance are two important concepts that affect its performance. Bias refers to the difference between the predicted values and the actual values. When the model has high bias, it means the predicted values are far from the actual values, leading to underfitting. On the other hand, variance refers to the amount the model changes when trained with different training data. High variance can cause the model to overfit the training data, modeling the random noise instead of the intended outputs. A good model should balance both bias and variance, achieving low bias and low variance for optimal performance. What is the trade-off between bias and variance in machine learning, and how does it affect the performance of a model? Answer: the trade-off between bias and variance refers to the balance between accuracy and consistency in a machine learning model. Bias represents the difference between the model's predictions and the true values, while variance represents the spread of the model's predictions around the average. When a model has high bias, it is consistent but inaccurate, while a model with high variance is accurate but inconsistent. To achieve optimal performance, a model must strike a balance between bias and variance, as increasing complexity can reduce bias but increase variance, and vice versa. This trade-off is crucial in machine learning, as it determines the model's ability to generalize well to new data and make accurate predictions. Define precision and recall. Answer: precision is a measure of how accurate a model or system is in identifying relevant information. It is calculated by dividing the number of true positives correctly identified relevant information by the sum of true positives and false positives incorrectly identified irrelevant information. This gives us the proportion of relevant information that is actually relevant. Recall, on the other hand, is a measure of how well a model or system is able to identify all the relevant information. It is calculated by dividing the number of true positives by the sum of true positives and false negatives missed relevant information. This gives us the proportion of relevant information that is actually identified. In other words, precision measures the accuracy of a model, while recall measures its completeness. A model with high precision is likely to have low false positives, while a model with high recall is likely to have low false negatives. A good model should aim to balance both precision and recall to achieve optimal performance. What is decision tree classification? Answer: decision tree classification is a method of building a classification model as a tree structure where data sets are divided into smaller subsets using decision-making rules. This process continues until each subset contains only one type of data, allowing the model to make predictions by traversing the tree from the root node to a leaf node. Decision tree classification can handle both categorical and numerical data, making it a versatile and widely used technique in machine learning. What is pruning in decision trees, and how is it done? Answer: pruning in decision trees is a technique that reduces the size of the tree to prevent overfitting, which improves the predictive accuracy of the model. Pruning can be done in two ways: top-down, starting from the root node, or bottom-up, starting from the leaf nodes. A popular pruning algorithm is reduced AO pruning, which replaces each node with its most popular class, and only keeps the change if the prediction accuracy is not affected. This approach simplifies and speeds up the model, making it more efficient. What is logistic regression and how does it work? Answer: logistic regression is a classification algorithm used to predict a binary outcome 0 or 1 for a given set of independent variables. It works by using a mathematical function called the logistic function to calculate the probability of the binary outcome. The output of logistic regression is a probability score between 0 and 1, which is then compared to a threshold value, usually 0, to determine the predicted outcome. The algorithm uses a combination of the independent variables to calculate the probability score, allowing it to make predictions about the binary outcome. What threshold value is used to classify any value above it as 1 and any value below it as none? Answer: the threshold value used is 0.5. Any value greater than 0.5 is considered as 1, and any value less than 0.5 is considered as none. This means that values close to 0.5 will be treated as none, as they are not strictly above or below the threshold. What is the k-nearest neighbor algorithm and how does it work? Answer: the k-nearest neighbor algorithm is a classification algorithm that assigns a new data point to a group or class based on the similarity between the new data point and existing data points. It works by finding the k most similar data points to the new data point and then classifying the new data point as belonging to the same group or class as the majority of these k-nearest neighbors. The algorithm is simple, yet effective, and is often used in applications where the data is not well understood or where the relationships between the data are complex. In KNN, k can be any integer greater than 1, and the choice of k depends on the specific problem being solved and the characteristics of the data. The algorithm is also known for its ability to handle nonlinear relationships between the data, making it a popular choice for many machine learning tasks. When using KNN to classify a new data point, how do we handle a situation where the k-nearest neighbors belong to different classes? Answer: when using KNN to classify a new data point, we handle a situation where the k-nearest neighbors belong to different classes by preferring the majority class. In this case, since 3 out of the 5 nearest neighbors are tennis balls, the new data point is assigned to the tennis ball cluster even though the other 2 neighbors belong to different classes. This approach ensures that the classification is based on the majority vote of the nearest neighbors. What is a recommendation system? Answer: a recommendation system is an information filtering system that uses a user's choice patterns to predict what they might want to hear or see. It analyzes the user's preferences and behavior to suggest personalized content, such as music, products, or movies, that are likely to interest them. The system is commonly used in online platforms like Spotify, Amazon, and Netflix to provide users with tailored recommendations. What is kernel SVM? Answer: kernel SVM, also known as kernel support vector machine, is a type of algorithm used for pattern analysis. It's a popular method in machine learning that allows us to use non-linearly separable data by transforming it into a higher dimensional space where it becomes linearly separable. This is achieved through the use of a kernel function, which maps the original data into the higher dimensional space. By doing so, kernel SVM can effectively classify complex data and make accurate predictions. In simple terms, kernel SVM is a powerful tool that helps us analyze and make decisions from complex data sets. What are some common methods of reducing dimensionality in machine learning? Answer: there are several methods to reduce dimensionality in machine learning, including feature engineering, which involves combining features to create new ones. Another method is removing collinear features, which are features that are highly correlated with each other. Additionally, algorithmic dimensionality reduction techniques, such as principal component analysis (PCA), distributed stochastic neighbor embedding (TSNE), and independent component analysis (ICA), can be used to reduce the number of features in a dataset while retaining most of the information. These methods help to simplify complex datasets, improve model performance, and reduce the risk of overfitting. What is principal component analysis? Answer: principal component analysis (PCA) is a statistical technique used to analyze quantitative data by reducing its dimensionality, removing noise, and extracting important features and attributes from large datasets. It helps to identify the most significant patterns in the data and presents them in a new coordinate system, making it easier to visualize and understand the data. What is the phone score and how is it calculated? Answer: the phone score is a metric that combines both precision and recall. It is calculated using the formula phone equals 2 *p *r/p plus r, where p is the precision and r is the recall. This score is a weighted average of precision and recall, and it provides a single value that summarizes the performance of a model. The phone score is 1 when both precision and recall scores are 1, indicating perfect performance. What do you understand by type I and type Roman 2 errors in statistical hypothesis testing? Answer: in statistical hypothesis testing, type I error occurs when we reject a true null hypothesis, meaning we conclude that there is a significant difference or relationship when in fact there isn't. On the other hand, type Roman 2 error occurs when we accept a false null hypothesis, meaning we conclude that there is no significant difference or relationship when in fact there is. In other words, a type I error is a false positive and a type Roman 2 error is a false negative. This highlights the importance of considering both types of errors when making decisions based on statistical results. What is correlation, and how does it relate to covariance? Answer: correlation is a measure that tells us how strongly two random variables are related to each other. It takes values between -1 and 1, where 1 means a perfect positive relationship, -1 means a perfect negative relationship, and 0 means no relationship. Covariance, on the other hand, is a measure that tells us how much two random variables change together. It is calculated as the average product of the deviations of the variables from their means. Correlation is a standardized version of covariance, which means it takes into account the spread of the data. In other words, correlation is a way to normalize covariance, making it easier to compare the strength of relationships between different variables. For example, if two variables have a high covariance but one variable has a large range, the correlation might be low because the spread of the data is large. By using correlation, we can get a better sense of the strength of the relationship between the variables. What is the formula to calculate correlation? Answer: correlation is a measure of the strength and direction of the linear relationship between two random variables. The formula to calculate correlation is not provided in a given context, but it is related to the formula for calculating covariance. Covariance is a measure of the direction of the linear relationship between two random variables, and correlation is a standardized measure of covariance. The formula for correlation is typically calculated as the ratio of covariance to the product of the standard deviations of the two variables. However, the specific formula for correlation is not provided in this context. What are support vectors in SVM? Answer: in support vector machines SVM, support vectors are the data points that are closest to the hyperplane that separates the classes. These points play a crucial role in determining the position and orientation of the hyperplane. If any of these support vectors were to be removed, the hyperplane would shift, indicating the significance of these points in building the SVM model. In essence, support vectors are the key data points that help the SVM algorithm learn and classify new data. What is ensemble learning? Answer: ensemble learning is a technique in machine learning where multiple models are combined to improve the accuracy of the results. This is done by taking the predictions from each model and using them to make a final prediction. The idea is that by combining the strengths of multiple models, you can achieve better results than you would with a single model. For example, a random forest with 100 trees can provide more accurate results than a single decision tree. This technique is often used to improve the performance of machine learning models in situations where there is a lot of noise or uncertainty in the data. What is cross-validation in machine learning? Answer: cross-validation in machine learning is a statistical resampling technique that uses different parts of the dataset to train and test a machine learning algorithm on different iterations. This helps to test the model's ability to predict new data that was not used to train the model, avoiding overfitting of data. It's like training and testing the model on different subsets of the same dataset, ensuring the model generalizes well to new unseen data. What are the different methods to split a tree in a decision tree algorithm? Answer: in a decision tree algorithm, there are three main methods to split a tree: variance, information gain, and Gini impurity. Variance is used when the target variable is continuous, information gain is preferred when the target variable is categorical, and Gini impurity is followed when the target variable is categorical. These methods help the algorithm to decide which feature to split on and how to split it, ultimately leading to a more accurate prediction model. How does the support vector machine algorithm handle self-learning? Answer: the support vector machine algorithm handles self-learning through its learning rate and expansion rate. The learning rate adjuster penalizes the hyperplanes for making incorrect moves, while the expansion rate helps find the maximum separation area between different classes, enabling the algorithm to learn from its mistakes and improve its performance over time. This self-learning capability allows the SVM algorithm to adapt to new data and improve its accuracy. What are the necessary assumptions for a linear regression model to be valid? Answer: before starting with linear regression, we need to check 5 important assumptions. First, the data should follow a multivariate normal distribution. This means that the variables should be normally distributed, and the relationship between them should be linear. Second, there should be no autocorrelation, which means that the observations should be independent of each other. Third, the variance of the residual should be constant across all levels of the predictor variable, which is known as homoscedasticity. Fourth, there should be a linear relationship between the predictor variable and the response variable. Finally, there should be no or little multicollinearity between the predictor variables, which means that they should not be highly correlated with each other. If these assumptions are not met, the results of the linear regression analysis may not be reliable. What is the main difference between lasso and ridge regression in terms of the penalty function used to avoid overfitting? Answer: the main difference between lasso and ridge regression is the type of penalty function used. Lasso regression uses a penalty function that is the sum of the absolute values of the coefficients, while ridge regression uses a penalty function that is the sum of the squares of the coefficients. This difference affects the way the models handle feature selection and coefficient shrinkage, with lasso being more aggressive in setting coefficients to 0 and ridge being more gentle in shrinking coefficients towards 0. What are some real-life applications of clustering algorithms? Answer clustering algorithms have several real-life applications, including customer segmentation for targeted marketing, recommendation systems for personalized suggestions, anomaly detection and fraud prevention, image compression to reduce storage, healthcare for grouping patients with similar conditions, and document categorization in search engines. These applications help organizations and individuals make better decisions by identifying patterns and grouping similar data together. For instance, a company can use clustering algorithms to segment its customers based on their purchasing behavior, preferences, and demographics, and then target specific groups with personalized marketing campaigns. Similarly, a search engine can use clustering algorithms to categorize documents and provide users with more relevant search results. How do we determine the optimal number of clusters in a dataset? Answer: there are several methods to choose the optimal number of clusters, including the elbow method, silhouette score, and gap statistic. The elbow method involves plotting the explained variance or within cluster sum of squares against the number of clusters, and the point where the curve starts to flatten indicates the optimal number of clusters. The silhouette score measures the similarity of each point to its own cluster compared to other clusters, and the optimal number of clusters is the one with the highest average silhouette score. The gap statistic compares the clustering result with the random clustering of the same data, and a larger gap between the real and random clustering suggests a more appropriate number of clusters. By using one or a combination of these methods, we can determine the optimal number of clusters for a dataset. What is feature engineering, and how does it impact the performance of a machine learning model? Answer: feature engineering is the process of creating new features from existing ones by applying mathematical operations or combining multiple features into a single column. This process can significantly improve the performance of a machine learning model by providing more relevant and informative data for the model to learn from. By developing new features, feature engineering can help uncover hidden patterns and relationships in the data, leading to better predictions, classifications, or clustering results. In essence, feature engineering is a crucial step in data processing that can greatly enhance the accuracy and effectiveness of a machine learning model.